Okay, today we're going to be talking about databases, specifically looking at the SQLite database, which is an example of a relational database. Um, there are a variety of database options available for Python, meaning that Python has um, libraries for interfacing with a variety of databases. Looking at the notes that I'd used, years ago for this class, I had a list of a dozen or so databases of which I've haven't heard of since. That there were Python libraries for. So the takeaway is essentially any kind of database that you might be interested in working with, you will most likely be able to work with it with Python. So there's a number of kind of common relational databases that are defined around the SQL query language. Popular ones include MySQL and PostgreSQL, which are two open source databases, Oracle, Microsoft Access, and more, including the SQLite that we'll be using. Then there are NoSQL databases such as the Zope database, which is really what kind of got Python popular a decade and a half ago. MongoDB, which is a newer database, and again, many more. So, what is a relational database? So, the key idea with relational databases is that they are based on set theory. And because they're based on set theory, it's possible to precisely define a query language. In this case, SQL, the first standard of which was published in 1986. So to be able to work with a relational database, we need to have some basic understanding of SQL. And this will be very basic. So the first thing is that the data are stored in tables, and tables are columns and rows. So you can think of columns as the particular variables, and rows are particular instances of those variables. So we create tables, and then we modify tables by inserting data into them, deleting data from them, altering the data that are in tables, and then we query tables, or we select information that are stored in tables for presentation to the program or the users. And then a database is essentially a collection of tables. So Python has defined a basic database API, and different database libraries are expected to conform to this database API. And with these interfaces, like what we'll be going over in SQLite, the creation, manipulation, and querying of databases is done directly with SQL commands and not with Python. So you basically generate a string that contains the SQL command that you want to execute, and then that string is executed by Python to perform it. There are ways that you can use Python and relational databases where this SQL is essentially hidden from you, and that's because the programs are using object relational mappers. So Django is an example of this. So Django is a popular web platform built on Python, and you define objects that correspond to different forms on your website, and then those forms are translated to the relational database behind Django, and that object to table mapping is done for you, and so you as the user of Django are not directly working with SQL. And then there are other like SQL Alchemy as a popular object relational mapper that is applicable to any application that you might be working with. So we're going to be working with SQLite, and you might ask why. It's basically because of its simplicity. So there's no configuration, there's no database manager, database administrator password, username, etc. It's so zero configuration. It's portable, so SQLite databases can be read on a variety of platforms and architectures. It's small, it's simple, it's got liberal licensing, it's reliable, it's convenient, and essentially since Python version 2.5, it's been integrated directly into Python, and that will also be common to other things like Ruby is similar. So essentially what you end up with SQLite is you have a file that is your database. Um, so there are limitations. There's reasons that you don't use SQLite for enterprise-wide applications, namely that it'll be slower than more complex databases for large complex queries, and there's no foreign key constraints, which is a data consistency issue that it's lacking, and it doesn't have a concurrency built into it. Okay, so I mentioned that Python defined a database API, and this defines a set of features that all Python database interfaces must subscribe to. And this is intended to protect the user from the details of the specific API for each of the databases, so that there's kind of a common way of doing things in Python, regardless of the particular database that you're working with. So in a Python database module, there will be 3 global variables that describe how this database API works. So there's an API level variable, and that says whether this module is compliant with version 1.0 or version 2.0 of the Python database API. If API level is missing, then that means it's not 2.0 compliant, the most recent version. Okay, so then there's a thread safety variable that can have values 0, 1, 2, or 3, and that basically says how threads, which are kind of a multi-processing concept, so there's multiple applications going on at once. 0 means the threads may not share the module at all, and then it's increasing to there's complete transparency to the threads with the module with level 3. And then param style is how parameters are spliced into SQL queries, and we'll talk about this more later, but it's a security feature, and there are different ways that you insert particular parameters into a query as you're building it, and these are the possible values that it can have. So if we import SQLite, and I always import SQLite 3 as SQLite, we can print what the API levels are and the thread safety and param styles are for SQLite. So in this case, it's 2.0 compliant. The thread safety is 1, that threads may share module but not connections. And the param style is Q mark, meaning a question mark. And that will be illustrated later in the notebook. Well, we might be interested in, how does this compare to other database APIs? So if we wanted to use MySQL, there's a MySQL Python library, which can be installed with pip. And we can explore the same issues here of its API level compliance, its thread safety, and its param style. And so here it's 2.0 compliant. Similar to SQLite, it can share the module but not a connection between threads. And its param style is format, which is C-style formatting. Okay. Psycho Postgres 2 is a popular Python library for interfacing with PostgreSQL, and again it can be installed with pip, given that you already have Postgres installed on your computer. And we can look at this, and it's 2.0 compliant, it's level 2 thread safety, and it uses PyFormat for its parameter style. Okay, so let's kind of go through how do we work with the database. So the first thing we do is we make a connection. And with SQLite, it's a .connect command where you give it the path to the, the, the database. In this case, I have a Seinfeld food database in my data directory, so I can make a connection to it. Okay, so what are some connection highlights? Well, maybe most importantly is that we can use the connection to create a cursor, and the cursor is what we use for executing the SQL commands. And we can, with the cursor, we can execute script, execute many. Actually, these are shortcuts we can do directly from the connection that behave the same as a cursor would. Another note is that we can create a database in memory, and that's if we pass it the name :memory:. And this will not write anything, it will not create anything on disk, and is useful for a variety of things, such as if you're just demonstrating something for a class lecture. Okay, so if we have a cursor, if we have a connection, we can create a cursor, and that's through the cursor command. So now I have a cursor, and cursors have a variety of methods, and what we'll basically use are execute and fetch, different versions of those. And so I've just put in here the help statements for those functions. So, like I said, we need to be able to work with SQL commands, and so we'll go over just some basic examples. The first thing is, how do we create tables? So here's an example that I've just pulled from one of my own programs. And so I'm going to create a table, and I have this optional if not exists. And so that's just kind of an error checking. If I try to create a table that already exists, I'll get an error, similar to our trying to make a directory for a directory that already exists. So create table if not exists, then I give it what the table name will be, and then what are the columns of the table, and this will be the name of the column and what data type will be in that column. So here we're creating a 3-column table with that are all text values. I should mention that if I don't specifically create a primary ID, SQLite will create a row ID, which is an integer, which is the primary ID of the database. Okay, here I can just create another table with just a single column in it, a single text column. And here's a more complex table creation, PyContext NLP results, where I have integers and text, and then these integers are being labeled as being foreign keys, meaning that these values of integers correspond to the row ID value in the table run args. And similarly with the class schema. Okay, so that's ways that we can create tables in a database. Given that we have a table, we want to be able to insert data into it. And so that's done with the insert command. And so we insert into what table we're going to run into and what columns we're going to insert something into. And then we have a value statement. And this is where that API param style comes in. And so for SQLite, you'll recall that it was a question mark. So we're using this question mark as a placeholder for values that are then being passed into this string with this tuple. Okay, so that's our insertion. And then we want to be able to select. And we can select with the select, and the asterisk is select all the columns from a particular table, or I can select a list of enumerated columns, row ID and label, from the table. I can select values from a table, where some particular criteria is satisfied. In this case, the run date equals to some parameter that I'm providing at runtime. So we have select, and select can be modified with a where statement. Okay, so just some important notes to keep in mind. Any changes that I've made to a database remain uncommitted to the file until I run the commit method of the connection object. And a second note is never use Python string formatly to directly generate a SQL script. So that's why we're using these question marks. If we use just straight Python string formatting, that runs the risk of a SQL insertion attack on your database. Okay, so this is what you don't want to do, and this is how you want to do it. So don't use the string formatting, use the parameter style of the DBI API to insert values into your execution string. Okay, after we've executed, run the execute method, the cursor object can be used as an iterator to access the results. Alternatively, we can use the cursor to fetch the next result, fetch all the results that resulted from the SQL command, or fetch many, where we can specify the n number of results that we want to return from the database. Oops, sorry. So here's just some examples of working with a database. So I'm creating a database in memory, and I'm going to create a table named class participants, and it's going to have a column called name, which will have a type text, and I'll have another column role, which will also have type text. Okay, once I've created that table, then I can insert into it. And so I'm just going to demonstrate a couple of different methods. So here I'm inserting a single row into the table base. So insert into class participants, into the table's name and role, the values, which will be inserted here into these question mark placeholders, Brian and teacher. Okay, so that's using the execute command. If I create a list of these name role pairs, then I can use the cursor execute many command method to execute this same SQL statement over all the elements in roster. Finally, just to kind of demonstrate that I don't have to provide all the column values. So in this case, I'm inserting into class participants just a name, so there's no role associated with this particular person, which is Homer. So now I've inserted these values into the database, and I'm going to use here the select command, and I'm going to select all the values from class participants, and then I will, after that execute command, I'll fetch all the results and loop through and print them. We see all those values, and then with Homer, where I did not provide a value for the role, it's provided the value of none. And as we'll see in this next table, none in Python corresponds to null in SQLite. So if we looked at a SQLite database with another application, we would see a null in that row column position. Okay, here's some stuff that I don't think I'll go over here just to look at, that there's different, if you have a user-defined type like a class, how do you store that in a database? There's a couple of approaches. You can think of just splitting the values of the attributes of the class into different columns of a table. Alternatively, you can convert the object into a string, store that string in the database, and then retrieve that string and convert it back to the object. And so there's a couple of different methods to approach that are illustrated here. One is defining a conform special method, and the other is if we call an adapter. And so we've define an adapter for the application. We're registering that adapter. The adapter takes our attributes of the object and returns it as a string, and that function is being registered with SQLite as a way of taking a point object and rendering it as a string. And just to we'll just execute that. We get the string back in both cases. Oops, got a typo there. Okay. And then once we have a string, we just need to write a conversion function that converts that string back to a particular point object. Okay, to give us something to play around with, I have a database that has all the foods that are mentioned in different episodes of Seinfeld. And we'll just use this to illustrate some of the different ways we can use the select command. So here I'm selecting all the values, all the columns from the table food types, and then I'm going to fetch all the results and print it. You may ask, how do I know what's in the database? And there is a master table in the database that you can look at. There is a very useful tool that I've used a lot, which is a Firefox plugin for SQLite databases. And here I've got it opened right here. So there's always a SQLite master table that tells you the names of all the tables that are in the database. And then I can use this to browse through the particular tables. I got episodes. You see that I have an ID, a season, and a name. Food types, which is what I just ran against. I have foods, which have an ID, a type ID, and a name. And I have a food episodes, which has a food ID, which is a reference to a particular food, and an episode ID, which is a reference to a particular episode or a foreign key. So if we go here and we execute the select all from food types, we print those. There's bakery, cereal, chicken, fowl, etc. Okay, here I'm just illustrating doing a select with joins. This was essentially to teach myself how to do joins. And so I'm selecting, I'm going to be creating a new table that essentially comes from joining rows from the foods database and the foods episode database. And so what I'm doing is I'm looking for where the foods ID equals the foods episode ID. And then I'm using the fetch many to return the first 30, and I'm looping through and I'm printing the results, and I've renamed everything that I'm keeping for my select command, the food's name and the episode name, which I rename as name and episode. And finally doing something similar where now I've added to my select command an order, which is going to provide rules for ordering how the results are sorted. In this case, I'll be ordering it by episode, which I assume will just be an alphabetical list by episode. And then I'm just going to fetch one at a time and let the user break out of it by pressing a key. Oops. I'm seeing a quote there. All right, so that's our first exploration with databases working with SQLite.